Okay, so we're looking at maximum and minimum problems today, and we're still looking at things that are modeled with a quadratic. So if A in your formula is positive, it goes up, and this point right here, that would be the minimum point, is actually going to be at the vertex. If we flip it upside down, make it frown, that's when A is negative, it's frowny, then this point up here is a maximum point because it's at the top of the graph, and that is still your vertex. So on the maximum minimum problems, we're basically just looking at the vertex. So up there where we have a little bit of room to write, we'll just remind ourselves how to find the vertex easily. So if you're not graphing, you would find the x-coordinate by doing negative b over 2a, and then you put this into your equation, y equals ax squared plus bx plus c, and that'll help you get the x and the y that is your vertex. We did some of that in the previous lesson, but I'm just letting you know on all of the maximum minimum problems, you'll be finding the vertex. So that makes it kind of easy, because basically that's where the minimum and maximum of your graph will be, is always at the vertex. So, looking at the first problem. I'm sorry these didn't copy especially well. Let me zoom in a little bit. It says you have a 500-foot roll of fencing in a large field. You want to construct a rectangular playground area. What are the dimensions of the largest such yard, and what is the largest area? So if we're thinking about this, we're making a rectangular fence. So kind of over here in the margin, I'm going to draw a picture. Make sure I have lots of room under the problem to work. So if we have a rectangle, generally speaking, you have a length and a width. Okay, so I'm going to call this length L and the width W. I know that's incredibly imaginative, but that's what I'm going to do. And so when we're looking at perimeter of a rectangle, you have 2 lengths plus 2 widths. That's how you get the distance around, which is where that fence is going to go. It's going around the outside. That's how I know that that's perimeter, because you're not going to fence the middle of your yard. You're going to fence around the outside. It'd be kind of weird if you had fencing in the middle. I don't know. It'd be kind of weird.
Why is it asking for perimeter?
Okay, because we have 500-foot roll of fencing that we're going to put around this. And so we're trying to figure out what that 500, which will be our perimeter,
Yes.
how we can do the dimensions to get the maximum area. So instead of P, we can substitute in that 500. So 500 feet will be the 2 lengths and the 2 widths. Now that doesn't help us a whole lot until we also realize that we're trying to maximize area. So the area is length times width. Everybody agrees with that?
Yeah.
So what I'm going to do is we're going to combine these 2 formulas. Don't get scared, it's going to be fine. We're going to solve this one for either L or W and then put it in over here, so we just have one variable. So you want to solve for L or for W?
L.
L? Okay. So for solving for L, we're first going to move the W's. So we'll subtract 2W from each side. We'll get 500 minus 2W equals 2 L's, 2 lengths. Then you can divide everything by 2. So we'll get 250 minus W, if I divide both of those by 2, equals L. So on our picture, instead of the L's, we can go back and write 250 minus W, just to kind of help us figure out what's happening. Or you could draw a new picture, but that just helps my brain understand what's going on. So why did we solve for L? We're going to take all of this and substitute it for L on the area formula, because it's the area that we want to maximize. So where the L was, I'm going to put in 250 minus W. And then we have another W over here. Okay, it still doesn't look very quadratic-y yet.
So now we can find it.
But now we can distribute, and we would get the area equals 250W minus W squared. That looks more like a quadratic because we have that squared in there. Now normally we like to have the squared on the beginning, so I'm just going to rewrite it, negative w squared plus 250w. Why do I want to do that? Because we want to find the maximum, which in this case, if it's a maximum, it's going to look like this if we graphed it. You're going to have an upside down parabola, which is why this negative is there. That flips it upside down. And we can find that vertex and it'll answer all of our questions. So, to find the vertex, so our maximum point. Our maximum is going to be the vertex. And so we're going to use, the formula is x equals negative b over 2a. We're using w, same thing. So we're going to do negative b over 2a. And that's actually going to be w, which is our width, instead of x. But it's the same idea when we were using x before. So that's going to be negative 250 over 2 times negative 1. So basically negative 250 divided by negative 2, we're going to get 125. So this just tells us what the width was back here on our picture. The width was 125 feet. So from here, we could work this out using just some arithmetic. Okay, if my widths are 125 and 125, that adds up to 250. And I know the whole thing is 500. And so if I take 250 here minus the width, that's going to make this also 125 and 125. The maximum area is always going to be a square, which I think we talked about a little bit in middle school. But that's how you get the maximum area. All the sides are going to end up being the same, 125.
So
Always or just in this problem?
Huh? Always. Although sometimes it's a little harder to figure it out. And so my width is 125 feet. My length is also going to be 125 feet. So my dimensions are 125 by 125, however you want to write that. And then it also asks, what is the largest area? So length times width, be 125 times 125, or 125 squared. And I have that worked out somewhere. That is 15,625 square feet. So that's the most area I can get out of a yard with that kind of fencing. Now, if this were the PSAT, which is coming up, and you knew that it's always going to be a square, how can we make this problem simpler?
Just find the width.
So 500 divided by 4
Oh.
also gives me 125 for all the sides. But we didn't know that, we didn't remember that from before. So you can always work it out this way. But if you get in your brain that the maximum area always comes from a square, you can take that fencing and just divide it by 4 on all sides, and then it becomes a little bit more fast and easy. And that's one of those tricks that shows up that people study when they're getting ready for the ACT, the SAT, any of these college prep type things. Now, let me talk about the calculator a little bit, because some of you really like the calculator. When we made this equation, if you like the calculator, you could work out this equation and still go over and graph it. So I had negative w squared, which I have to use x on here, but same thing, just different letter, plus 250x. I don't know what my screen is set on right now, so, oh look, I think it's showing part of the graph. So let me change my window really quick. So I don't need any negatives. Let's make this a whole lot bigger. Let's make it 300. Just go from 0. Oh, but this number needs to be bigger. Let's make it 20,000. And I'll make this go by thousands. You don't have to change this. It's just where it's going to put the tick marks. But anyway, we get it on a window where it'll show up. You can also use your trace feature and just see where the top of that is. And so it actually comes out evenly. So 125 is the width, and then this is the area. And you can get those answers right there. But you still have to write the equation first. So I don't know if this is actually super fast for you, but
What did you put your window on?
I did 0 to 300 for the x's, since I knew that since the fencing was 500, I was just figuring 300 is a little bit bigger than half, so that works. And then on the y max, I went like 20,000 because I knew it was going to be a big number. It's lots of.
Okay, so how would I find the vertex on the calculator?
On the calculator, you can also find the vertex above the trace key.
Yeah.
Right here, it says calc. If you do second calc, there's actually options for finding the maximum and minimum. And so if you go in and tell it to find the maximum, it's going to give you a left bound, which means just go a little bit to the left of that maximum point. Right bound goes a little bit to the right, because we talked about some graphs can have more than one little hill on there. It's not just saying, okay, I know that the maximum's in here somewhere. On guess, you can just hit enter. You don't actually have to guess. And then it's telling me it's 124.999999. You have to round that up to 125, but I think you guys are capable of figuring that out. And then this gives you the area.
Round to 124.
No, it would not round to 124. Okay, your elementary teachers would be very disappointed if you did that. Okay, so that's just another tool that you can use. If you're doing something like the PSAT, the SAT, the ACT, knowing that the maximum area always comes from a square, you could do this a whole lot faster. So that's a tip that I'm giving you, and you may use that now that you know. Yes?
So, like, how do you know when to round? Like, on a starter, it was 7.6.
So when it's like 0.999999999, that's a pretty good guess. You want to round it up. If you have like more random numbers in the decimal, you usually want to keep a decimal place. It also kind of depends on what they're asking. Like if they want it to the nearest foot, and then you don't. In your science class, Mr. Scroggins will talk about significant figures at some point, and then there's rules for how much to round the answer depending on how much the numbers in the beginning are rounded, just to keep your accuracy. I'm not going to go into that because we have 3 more problems to do. But there are some rules that can also help you figure that out if it's not in the directions. Okay, so this is a slightly more complicated problem that we cannot solve using that trick that I just showed you. So we'll have to do it the long way. It says you have a 1,200-foot roll of fencing and a large field. I'm sorry, I'm a math teacher. That's 1,200-foot roll of fencing and a large field. You want to make 2 paddocks by splitting a rectangular enclosure in half. What are the dimensions of the largest such enclosure? So if we draw our little rectangle, I'm going to do that kind of off to the side here. We are going to have fencing all the way around the outside and then a fence in the middle to split it in half. Okay? So that means I'm going to have 3 widths and 2 lengths. Okay? If we're thinking about it that way. So, we want to make the largest enclosure that we can. That's another way of saying that they're looking for the maximum. Okay? So the amount of fencing that we need on this is going to be a little different. I'm going to have 3W, 3 widths, and 2 lengths. So 3W and 2L. And it's going to add up to 1,200 for our first equation. And then the area is still length times width. Question?
Could we, I don't know if this would work, but like if we were just to divide 1,200 by 2 and then just find that,
well,
would that work? Or
I don't think so. Not for this one, because this one's definitely going to be a rectangle. Yeah, because they share that in there. Kind of messes it up a little bit.
Okay.
See, there's not as many shortcuts for this.
Okay.
So let's go ahead and solve, let's just say for the length again. Just to make this similar to the last problem, not change a whole lot of things. So we could subtract the 3 widths off both sides. We'd have 2 lengths equals 1,200 minus 3W. Or do you like having the W's in front? It doesn't matter to you. I'm going to change it just because I like it better, that negative 3W plus 1,200. It looks more like a slope-intercept form that way. It doesn't really matter, but just because, I'm going to switch that around. Okay, and then divide by 2. So everything's going to get divided by 2. So the length is negative 3 divided by 2. We could keep that as a fraction. You can change it to negative 1.5, which is fine. And then 1200 divided by 2 is 600. So again, all of this is the length. And so we can put that into this equation right here for this length to combine everything together. So then the area would be negative 1.5 W plus 600 times another W. Yep, and we can simplify this a little bit by distributing that out. So then the area is negative 1.5 W squared plus 600 W. It just adds another W onto both of those. And so when we're looking for that maximum again, we're looking for that vertex. And so this is W instead of X, so the W will equal negative B over 2A. Remember that the second number is B, the first number is A. That's why I rearranged it in the beginning. So negative 600 divided by 2 times negative 1.5. So negative 600 divided by negative 3, which gives us 200. And this was in feet. So 200 feet would be the width. So let me zoom out and go back to our picture. So that means we have 200 here, 200 here, and 200 here. So we've taken care of 600 feet out of the 1,200. So if you go back, we had 1,200 to start with, and we have 200, 200, 200, which is 600. That means that we have 600 left to do this length and this length. And so those would both be 300. You could also take this and put it in for W in one of these equations and figure it out that way. So the width is 200 feet, and then the length would be 300 feet. And that allows us to solve the problem. So it is just a little different. Now, when JC was asking about a shortcut, something that just occurred to me is you could take 1,200, divide it in half into 600 and figure out, okay, how do I do 600 for these two and for those three? That's a shortcut that would work. I hadn't thought about it, but it would, because if you take 600 divided by 2, you get 300, and 300 divided by 3, you get 200, 200, 200. And then you could work it out from there. So that gives you the maximum area. It doesn't actually ask you what the area would be, but we could figure that out pretty quickly by multiplying them together. So that maximum area, if you were asked for it, would just be the 200 times the 300. So 2 times 3 is 6, and then we get 4 zeros and feet squared. So it doesn't actually ask on this problem, but sometimes they will. So I'm just adding that on to help you out in case that shows up. So that's 60,000 feet squared. Okay. Yes.
No.
Okay, so let's go over to the next page. I'm sorry. Oh, yes, I can go back for just a second. So just that last part's the maximum area. We took the 200 times the 300 to get just the maximum area. It didn't ask for it, but sometimes they do. So I'm trying to make sure we figure that out.
How would you do that on the calculator?
200 times 300.
No, I mean
The same way we did last.
Oh, so the same way that you did last one. You just have to figure out the vertex. And it would give you the 200 and the 60,000, and you'd still have to figure out the 300 by yourself if you did it on the calculator. So it doesn't quite give you everything, but it would give you a lot. All right, so let's go over to number 10. I'm try to zoom in because it's really tiny print. Okay, your factory produces lemon-scented widgets, whatever a widget is. You know that each unit is cheaper the more that you produce. So the more you make, the cheaper it is. But you also know that costs will eventually go up if you make too many widgets due to the cost of storage of the overstock. So there's like a magic number that you can make and make the most money. That's what we're looking at. The guy in accounting says that your cost for producing X thousands of units a day can be approximated by this formula. So X is how many widgets you're making in thousands, and C is your cost. Look, they wrote the equation for us. Find the daily production level that will minimize your costs. So I will do this two ways. We'll do the calculator in a second. I want to talk about the non-calculator way first, because sometimes we're not allowed to use them. So want to make sure we do both. So the maximum, remember, we're going to find the vertex. So x is negative b over 2a. So it's going to be negative 8.504. So that'd be positive 8.504 over 2 times 0.04. So it's going to be 8.504 divided by 0.08.
Oh my god.
And so you just do that really quick. Actually, hopefully they would not give you numbers like this if you were not allowed to use a calculator, but at least I'll give you the idea. So it comes out about 106.3. Remember that is 1,000 because it said so up here. This is our equation, and it's x thousands of units a day. And so that's how many I should make to maximize my costs. So if we want to write that in normal numbers, that'd be 106,300. That just looks better to me, and that is widgets. I should have labeled that. Whatever a widget is. It's like a thingamajig or a doohickey.
And
They're lemon scented, though, so that makes it all better.
wait, what
so-
are widgets and why do we need this many of them?
Okay, so this is the magic number that's going to give you the maximum amount of...
widgets that you should purchase.
Okay, now, it doesn't ask for this. Oh, I'm sorry, it's not maximizing cost, it's minimizing your costs. We're trying to minimize costs, but it's still the vertex. And then, if we want to know what our costs are going to be, we could put this 106.3 back into this equation. But instead of doing that right here, well, actually I'll just do it really quick because it's a calculator thing. So times, I would have to use 106.3 the way it was originally written, squared minus 8.504 times 106.3 plus 25,302, if I can copy that correctly. So you just take this and put it back into that equation and then use your calculator. And I do not have that worked out, so I'm going to work it out right now on my calculator. 106.3 squared minus 8.504 times 106.3 plus 25,302. Okay, so then my costs, which is C, would come out to be $24,850 and like 1 cent, which we'd probably just round that off normally and just call it $24,850. And so if I wanted to know what those, that's the minimum costs of production, which if you minimize costs, that maximizes your profit. All right, so let's talk about what we would do with the calculator. If you were allowed to use a calculator, which it would be nice, and we could put this crazy formula in, we'd go to the y equals menu and go ahead and type this minus 8.504x and then plus 25,302. Now, I might want to go ahead and just fix my window because look at how big that number is.
Yeah.
So my y's quite possibly could be bigger than that. So I'm going to go into my window. So in my x's, I might want to be big too. So my x's, I might want to go from 0 to 150,000. The scale doesn't matter. That's just where it puts the tick marks. And then over here, I don't know. I might want to use 100,000 or something like that. Sometimes you have to play with it a little bit and see what's going to fit. Go over to the graph and hopefully, what did I do?
You didn't put in a max.
Oh, you know what I did was I forgot that we had these rounded off in thousands and I really just need to go past 100. So instead of 150,000, how about 150? I was thinking in thousands, sorry. So now you can kind of see
Why is it straight line?
a piece. That is an interesting question. Let me make sure I typed that in right. I did. So what it is we're probably just seeing a portion of
Yeah, I got into that.
this. So let's do this. Let's go to the window and we'll do like 500 for the x's. And then for the y's, I think we're good. The y's are good. So we might not quite see. When I did this, can you see that it's starting to kind of curve upwards? This is a super fat parabola. We're just getting a portion of it.
It's not working.
And so all I'm going to do is go second calc, and I'm going to tell it to find the minimum because this is just hard to read.
What's your Y
So the
max?
left bound, huh?
On your window, what's your Y max?
I think I did 100,000.
You did.
Okay, so I'm just going to go way over here to make the left bound, and I'm going to go
What's
way
your
over
Y
to the
min?
right. I'm not really sure. We'll say about right there.
It's not working.
And then it'll tell you that your minimum is 106.3 thousand widgets, and it will also give you that minimum cost as well. Same numbers that we got by writing it out and using the algebra. But this is kind of rough. Sometimes the graph just isn't super friendly. Yes.
I got it. Mine isn't working and I can't figure it out.
Okay, right now I don't have time to problem solve the calculator, but I will look at it in a second. Okay. Usually it's just a matter of like you accidentally hit a character you can't see, or there's a minus sign instead of a negative on there. I don't know. So anyway, so I'll just draw that little picture out here. So we had like just the very little bit of that widget. I'm sorry. So this was the widgets that you were making, and then this was the costs. So we're just getting like a portion of that parabola, but the portion that's negative doesn't really matter because how do you have negative widgets in your production? You don't. And so that minimum value was in here somewhere at that vertex, and it was at 106.3, 24,850. It's where you minimized your costs. And you can make big bucks working for big companies and doing crazy math like this and figuring out what that equation is and what the minimum costs are. Lots of money in it. Insurance companies pay rather well for people to figure things like that out. All right, let's take a look at number 11. You run a canoe rental business in a small river in Ohio. You currently charge $12 per canoe and average 36 rentals a day. It's pretty cheap, I think. An industry journal says that for every 50-cent increase in rental price, the average business can expect to lose 2 rentals a day. It's a little complex, but we'll break that down in a second. Use this information to attempt to maximize your income. What should you charge? Okay, so let's just say that X is the number of 50-cent increases. Okay? Because that's really what we're looking at for our unknown. How many of these 50-cent increases should I do? Because we know that how it's going to change based on those 50-cent increases. Okay, so if we're looking at this, your price that you're charging is the $12 you have now plus 50 cents per 50 cents increase. I know that's a little redundant there, but it's $12 plus a certain number of 50-cent increases. Okay, your rentals right now are 36, but it tells us that you're going to lose 2 per day for every 50 cents it goes down. So it's going to be 2 per every 50 cent increase, so minus 2x. Okay, so your income, what you're actually bringing in that we're trying to maximize, is whatever you're charging for the price times how many rentals you're doing, right? Price times rentals. So right now it'd be 12 times 36, and you could figure out what you're currently making. Actually, it's kind of interesting. Let's do that. So, so 12, if over here I'm making, right now I'm doing about $12 per canoe, and I'm doing about 36 a day. So if I multiplied those, right now my income per day is $432 a day. And so we're hoping to make a little bit more than that. Okay? So what we're going to do is we're going to put this in for the price. I'm going to put a little I for income. And that's 12 plus 50 cents per that. And then we're going to take that times 36 minus 2x. This is where quadratics actually show up in real life most often, is something where you have to look at one thing and write an equation, another thing, write an equation, and then you're putting equations together.
Right.
Right, okay. And then we have to distribute everything to everything. We have to do FOIL. So 12 times 36, we already know, is that 432 that we were already making. And then we have to take that 12 times the negative 2x, that's minus 24x. 50 cents is a half, so basically half of 36 is 18x. And then I have to take the 50 cents times the negative 2, which makes it negative 1x squared. All right, I'm going to rearrange this so it looks a little bit more like what we're used to. I'm going to put the negative x squared on the beginning. These are like terms that we can put together, so that's minus 6x, and then I'm going to put the plus 432 on the end. So if we're just strictly using algebra, what this is going to look like, we're maximizing our income. So this is a parabola. It's going to be like this. We're looking for that vertex point at the top. So we can do our x is going to be negative b over 2a. So it's already negative 6. If I make it negative again, it becomes positive 6 times 2 times negative 1. So I get 6 divided by negative 2, which is negative 3. Now that's interesting, and most of the time if we get a negative on this, we're going to question ourselves, but this is actually what's going to work out. So if I did negative 3, 50-cent increases, what does that actually mean we're going to do to the price? We should lower the price. So negative 3 times 50 cents actually means we should drop the price $1.50. So instead of charging, what were we charging? $12, we should take off $1.50, which would be $10.50. So I'll write that out. So right now we're charging $12. We should take $1.50 off of that, which means we should charge $10.50. And we will actually make more money, in theory.
Does it want to know how much?
It doesn't ask how much, but we could figure it out by putting it back in if you want to.
So would we plug that
Doesn't come
in?
out.
So would we?
So the other thing we can do, sometimes these are just messy. You could go in and graph it really quick. So let me just go in. Did I mess up any of these? I feel like it's okay.
Is it wrong?
I don't think so. I don't know. We'll find out. Let's check it. Negative x squared minus 6x plus 432. So I don't think we're going to need the big window we had on the last one. So if you hit your window key, so the prices were I guess this was the number of increases. We can probably just make that 10. 10 50-cent increases is beyond what we were looking at. And then for the maximum profit, we were looking at $432 a day. We're probably safe making that 500, which means I'd have to change this down here. I'll just make it 1. It'll be
You
fine.
still don't see the whole thing, but you see what it's supposed to do.
Yeah. So then let's look at the graph. We can see a lot of it.
Yeah.
You know what we might do, though, since we had a negative? I wasn't thinking. On the window for your x's, to go from like negative 10 to 10. Sorry. Just trying to get us where we can see the whole thing. And so it is looking like our maximum profit is over here. So
It would be negative.
let's trace. I think we're okay. If we go over to that negative 3 that we were looking at, it comes out about $441-ish. The other thing you can do when you hit the trace key and you're in trace mode, you can type -3. It'll give you this little window down here. When you hit enter, it'll tell you exactly what that is. So 441. And so that would be the maximum that you would make. So since we were making 432 a day before, it's a little bit more. 441's a little bit more. So it's good. Now, the worksheet for this is really short.